Hello, my name is Nicholas, and in this video I'm going to give you an overview of my Swarm research project and the simulation which I've developed for that project. The idea behind this project was to research into swarm intelligence and swarm robotics, and to build a simulation which allowed me to explore some of these concepts. The idea of swarm intelligence is to create, rather than one huge monolithic solution to a problem, which is able to go through all of the information and come up with a single answer which is correct, to create lots of much smaller agents which each have only a small awareness of the problem and which provide a small part of this overall solution. When applied to swarm robotics, this usually means that rather than building one very complex robot which is capable of performing many tasks, we create a large number of smaller robots, each one capable of performing one specific task. And by allowing these robots to communicate and cooperate, the group of them collectively can perform the task and solve the problem in a way that is theoretically cheaper, easy to build, easy to maintain, and easy to upgrade than building one single solution. My simulation addresses exploration of inhospitable environments. In this case, exploration of another planet. This could be the surface of the Moon, the surface of Mars, or some theoretical exploration of planets yet undiscovered. So what we have in our simulation is down the bottom an interface which has a lot of the controls which are available to us, and a view of the world. In the world we already can see a number of objects. These grey things are rocks, which are objects of interest to the swarm. These are things which we require to be collected and processed to gather scientific information. And these red flags, which represent places of mineral deposits, which the swarm would like to dig up and then process and bring back. This central object is the shuttle. This represents the point which the swarm enters the world, as in the shuttle has just come down from space, landed, and has then released its robotic team into the environment. This shuttle also forms the central hub of the operation, performing two key features. Firstly, being able to process these rocks, and secondly, being able to repair robots that become damaged through wear and tear or through accidents and so on. How my swarm works is it's divided into three different types of robots. The first type, movement robots, are small robots which are capable of moving around the environment, pushing objects around, collecting rocks, and interacting with the environment to an extent. The second type of robot are scout robots. These robots are much faster than movement robots. They have a much larger visual range and a much larger communication range. And the job of these robots is to spread out to form a network and to gain visibility of the environment. These robots then also pick up tasks that the swarm needs to act on and communicates those tasks to the swarm's members. The third type of robot is the task robot. This robot represents very specific hardware equipment designed to tackle a very specific task. In this case, the task robot is able to dig at these ore deposits and retrieve the resources that are buried there. Currently the simulation is paused, and if I get rid of these robots, we can see how the simulation is expected to function. Firstly, this shuttle would land and then create or release a number of scout robots, which will then spread out into the environment, forming communications and visual awareness of the environment around them. We can show that these scout robots have a very large visual field, and within this visual field they are able to identify things like other robots, rocks, and these ore deposits. Things that the swarm is interested in and things that the swarm is required to act upon. We can also show the communications that are formed between these scout robots, showing how these scouts can communicate information about the presence of rocks or the presence of jobs that need to be fulfilled. We can also see that whenever new scouts are added, the rest of the scouts will again ensure that they maintain distance with the scouts nearby to ensure maximum coverage of the environment and effective communication lines. After the scouts have been deployed, movement robots are then deployed from the shuttle. These movement robots are given tasks by the scout robots, and they then move through the environment to perform those tasks, mainly collecting rocks. What we'll see here is these robots have become damaged and are no longer functional. And in a similar way to how the movement robots retrieve rocks, the movement robots will also retrieve damaged robots. When rocks or damaged robots come back to the shuttle will either take those rocks, process them, and remove them from the simulated world, or take those damaged robots and repair them so that they are then again functional. The third type of robot will then be released, the task robot. How the task robots work is they pick up requests or information about these dig spots within the world, and they then request that they are moved there by movement robots. Once they arrive at those tasks, they will begin to drill and bring up those resources into the world, which will then appear in the form of rocks. Now I'm going to talk a little bit about how the robots in the swarm actually work. Each of the 3 robots is created from one single bot class. In this bot class there is information about how a bot can function, how a bot can move around, things that apply to a robot like whether or not it is damaged, whether or not it has a task that it is currently performing, and also some of the high-level processes of how the robots communicate with each other. The robots have a memory of a single task, and that single task represents whatever they were currently doing, and is simply used to help them remember what they were doing and help them decide what they're going to do next. From this main bot class, the 3 different types of robots are extended. So the movement robots, which are given the ability to push objects, the scout robots, which are given the ability to identify tasks that need completion, store those tasks in an internal list, communicate those tasks to other scout robots, and delegate those tasks down to robots that are capable of fulfilling those requests. And task robots, which are capable of performing specific hardware functions within the environment. If I enable our debug information, I can click on any object within the world to see information about that object, such as what it is, what its position within the world is. Alternatively, clicking on flags will show us the type of specific function required at that location. Or clicking upon a robot will show us what type of robot it is and whether or not it currently has a task that it is fulfilling. You will notice that movement robot that I had selected has a push type task, indicating that that robot is going to go and push an object to retrieve it. Clicking on our task robots, we can see that task robots have some extra information. They have a number of helpers that they believe are assigned to them. Because task robots cannot move themselves, they rely on other robots to push them where they're going, which means that whenever they need to go somewhere, they need to request help from the scouts nearby. Those scouts will then find movement robots who are able to help that task bot get to where it needs to go. When a task robot has helpers, it no longer needs to request help from the scout network. And so that counter is simply there to help the task robot understand whether or not there are robots currently assigned to help it accomplish whatever it's trying to do. And as we can see here, this task robot is now being pushed, so it now has a helper, which means it can stop requesting assistance from the network. And we can also see what's happening inside of our scout robots. Now, most of what a scout robot's information is that requests that it has identified within the environment or which it has had communicated with it from other scout robots. Now these requests store a position, they store an owner ID, and they store a type or a number of different abilities which are required to fulfill that task. Common ones are dig type tasks, representing these flags, and push type requests, which represent either rocks or task bots, or damaged robots. This internal list is clipped to a maximum of 20 requests, and these requests are spread and sorted through the Scout network using a hop counter. Every time a Scout bot identifies a task, it will communicate that task to every Scout bot it can communicate with, and those scouts it communicates the task to will then decide what to do with that request. If their internal list is full, they can choose to ignore that request, and depending on the hop counter of that request, that is how many times that request has been passed from the source of the information, they can also choose to ignore that request, choose to add that request to their internal request list, or if they already have a request matching that ID that is further from the source of information, they can choose to update the information about that request. The Scout robots will delegate information down to any robot that they can see within their immediate vicinity that is capable of fulfilling that type of request. So this Scout robot here has 2 push type requests, and so it's going to be looking in its area for robots that say, I can handle a push type request. As soon as movement robots move into its area, it's going to try and give that movement robot that request. The movement robots are also smart about how they take on new requests. Movement robots store the request that they are currently completing, and when given a new task to complete, they will compare that task with the task they are currently completing to identify whether they are closer to their current task or to the new task they've been given. They will choose whichever task they are closest to and complete that task, meaning that if there are rocks which have been identified far out on the edge of the network, and rocks which have been identified much closer to the center of the network, the rocks which are closer are more likely to be retrieved first. This also means that if we have movement robots being given tasks to collect rocks, if they pass by a closer rock, they will collect that rock first, improving the general efficiency of how the movement robots complete the tasks they are given. So within our swarm, we have robots which are capable of exploring the environment, identifying tasks which need to be done, communicating that information, and delegating that information down to robots capable of performing those tasks. We also have robots which are capable of performing basic and generic types tasks, such as pushing objects, retrieving rocks, retrieving damaged robots, and moving around the environment. We also have robots which have very specific hardware functionality, which are capable of being given tasks recognized by the network and requesting resources from that network to help them accomplish that task. In this way, we can create new types of task robots, robots with specific abilities, throw them into the network, and the network would be able to identify tasks which they can complete, communicate those tasks to them, and that robot would then be able to request any resources it needed from the network to help it accomplish that task. This swarm only has 3 different robot types, but more robot types could be added to extend the functionality of the swarm very easily. If we look at our interface just quickly, we can see that we have the ability to manually spawn different robot types by selecting a type and clicking. We can also spawn rocks, as you may have seen me do. We also have the ability to select specific robots to see the information that they've currently got and what tasks they currently have. We can pause and play the simulation. We can turn on and off the debug information in the top corner. We can also show and hide the vision range of the different robot types. We can also show the communications occurring between the robots, both these communications between Scoutbots and Scoutbots, where requests flow through the network, and these communications where requests are delegated from Scouts down to robots that are capable of fulfilling those requests. We can also very easily identify circumstances where the network becomes disjointed or broken apart. We can also toggle the ability for the simulation to automatically spawn tasks based on a timer, which will gradually fill the environment with rocks and flags that the swarm can collect. And we can also show copyright information about the simulation. The interface can also be minimized and maximized.